Today we are going to do the assignment of 3D CAD designing for the Fab Lab Academy. This is Ghassan Yusuf from Fab Lab Academy Bahrain, and let's start our tutorial. Today I am trying to do a filament spool holder for my 3D printer, which is at my bag, and I took the measurements. There are as you can see, there are two holes over here, and then the body of the 3D printer is inclined. So I have to design this, and the thickness of this sheet of the 3D printer is 7.5 millimeters. And the distance between the two holes are 16.3, and the distance from the upper hole to the side is 10.7, and the lower one is 15.9. So, and the distance between these two holes and the main hole that will hold the spool is like 100 millimeters off. So we are going to use Autodesk Inventor to achieve this. So bear with me. Now let's start by starting our program, Autodesk Inventor. By the way, this is my favorite 3D designing software. It's very similar to Fusion, but the layout is a bit different. Even the keys are somewhat in common. Okay, since we are going to build a part, so we don't need to do an assembly. So let's select a part. I'll put the design in front of me so I could directly implement. Okay, as you want to design anything 3D, you need to know that everything starts from a sketch. Without a sketch, you can't make a 3D model, especially if you are talking about a part. It's not like a clay that you can form. So let's start. Okay, so after, give the part a name, because this, if you forget this later, it's very hard to remember what was this part name. So let's say okay, now what we have to do is we have to start with a sketch, and then you select the plane that you want. This is the XY plane, so I will select the XY plane. And now we start our sketch by drawing the two holes that we have. Now this is, the diameter of the two holes is 3.5. Now something that I need to show you is they are a bit advanced techniques, because I don't want to every time put these dimensions. So I want this circle to be exactly the same. There is here in the toolbar, this is the toolbar by the way, and there are some tabs based on what you need. So this is an equal sign. We select the equal sign, we select this, and then voila, now but they are both the same. Now the distance that I took for the two holes is from the corner of this circle and the other corner of this circle. But the dimensions cannot become from corner to corner. They take the midsection. So the mathematics says, like, we put the distance from the corner to corner, which is 16.3, which is by default millimeters. If you need an inch, you put an inch. But we need to add the one circle, because from the center to the center, it completes one circle. So we will say plus this dimension. You click the dimension, which is D0, and it gives me the exact distance. Now, to keep them in middle from the center, we can make like this, okay, and select the distance itself, and then divide it by 2, and it happens. Now, First things first, we are going to build the circle. Now, I don't know how high I want to put the circle that holds the spool, but let's assume that we know something. Now, we have an inclined line. We have to draw it, which is this, okay? Now, from here to here, and I want to change the way this looks. Okay, I guess it's not the most appropriate way. Let's move this and create two lines. This is one, and this is another one. Now, the distance from here to here, as I said previously, it's 10.7 millimeters, and then because it's half a circle, we plus, which is this divided by 2. Okay, now from here to here, which is 15.9 millimeters, plus the same thing divided by 2. Sorry, what happened? 15.9 plus, which is this, divided by 2. So, yeah. Now, what we have to do is to bring this to be in contact with this line. Or just like this. Yeah. But we don't know the inclination. Okay, there is another way. So in order to know this, because I took it from center, so this is and then we center them like this to the center, this to the center. Since we took the center to center, it's going to give us the areas that we need to now. To get the proper inclination, it's very easy right now. This to this, and this to this. As you can see, the line is going in the proper direction. Now, let's take the trim, or we don't need to trim it right now because we need it for a little bit further. Now I have to decide how big is the box area. Let's say I would give it 40. And the distance from the corner to the middle, 40 divided by 2, so that it's in the middle. Okay. Now what we have to do is like try to make this box go in the opposite direction, upwards, because we don't want the spool to be held like this, because it's going to make a heavy weight on the spool holder. It might become inclined after a while, but when you make it like this, it has like the leverage. So what we are going to do is Um, you can draw it just like this, and then the other tools, as you can see, is the parallelization. So we want this to be parallel to this, so it's going along. Now we need to trim. Okay, trimmed. Now what we have to do is like to, let's say this is the circle, and we need the distance from this circle to the center of this place 100. Okay, but I guess it's better to keep it because the spool that I have is small one, so let's say 150. It better be that way. Now I want, okay, there must be, okay, now from here to here is going to be this divided by 2. As you can see, because this is not constrained, so it moved. So what we have to do is like to put it back. So let's constrain it first. Okay, and then we can trim those because we don't need them. Just to maintain the spaces, because I don't want the software to just, because if you don't specify a distance, it is going to assume that you don't care about the distance. So it will, anything that is constrained to you, to one of the objects, can move it away. So, okay. Now the distance here is going to be this divided by 2. And I don't know why I kept this, to be honest. And then because we didn't specify the length of this, so by pulling this, it's expanding, as you can see. Okay. Now let's draw another circle tangential to this. Trim. Tang, tang, tang. Okay. Um, this won't be a good practice because these walls are going to be weak. So what we have to do is like to make it a little bit bigger. Let's say I want it this much big. Okay, and see. Give it a dimension. Let's say this is 60. Okay. So let's trim the other stuff. Now what we have to do is like to extrude it, and then extrude it to the thickness of this plus the thickness of the 3D printer wall, and then twice more because we need to make it hold from both sides. So now we have to extrude this shape. Okay, so let's make it this way. Let me make by pressing F4 you can hold the mouse and move the shape. So there is something that I don't want to share, so I hold Shift. Let me just try it again. Thank you, my friend. Okay, so The wall is 7.5, as you can see here. So after 7.5, we need at least 4 millimeters plus 4 millimeters more. So 7.5. Thank you. 7.5, and then plus 4 plus 4. And now there is something that you need to know. You can't put the size exactly the same size. If you put 7.5 and the wall is 7.5, your object will not go in and you will need to struggle with it. So you have to put 7.5 plus 0.2 or 0.3 millimeters as a gap. So now we have this object over here, and now we have to cut the thickness of the wall over here. And how can we do this? We share the sketch. There is right click, share sketch, and then we go to the origin. Yeah, we want to make a new sketch over here. Cut the shape in half. Now what we have to do is like we want to take away this part. So come on, man. Okay, finally. But we want to subtract. So how much we are going to subtract is exactly this amount, 7.5 to. Let's hide the sketch. Now to make it a bit look nicer, so we can select the fillet. Okay. We don't want any sharp edges, so let's use this fillet all over. Okay. Now let's make fillets over here as well, but let's say it's 2 mm. And a chamfer over here. Chamfer is not like a fillet. Fillet gives it a round feeling, but chamfer is like a cut. So by pressing home, it takes you to the home uh, sketch. Now we need to do something, which is make the holes of. We go back to the sketch. We have to reveal it, visibility. And then we extrude. Okay, we need it to go on the both sides. And then where's the other one? My God, sometimes it gives me a hard time. Okay, let's do the first one, and then we go to the other one. We wanted a subtraction. Same thing. Yeah. Okay. So subtraction as well. And hide the sketch visibility. What I'm going to do is like I'm going to use 3 mm screws, and we are going to use the 5.6 mm nuts. So in order to keep the nuts in their place, we either make a wall for the nut to go in, or we can engrave in the same body of the uh, 3D printed 3D printed part. So let's engrave it inside. New sketch over here, and then we select a hexagonal shape. Okay, this is one. This is two. Now we need this to be parallel so that they don't move around as they are free. We use this, and then we have to specify their size. And now let's say if I took the dimensions of both and I want this to equal this, when I press here and just select the other dimension, it will automatically uh, use the previous the first one selected dimension. This is f of x, as you can see. F of x, that means this is a function following this dimension. So usually the nuts are 5.5, but as I said, if you want the things to fit in, you have to make it a little bit larger. So we make it 5.6 or 5.7, but 5.6 should be nice enough and tight so that when the nut goes in, it doesn't come out. We do some kind of engraving just to cut, and then usually those nuts are 2 millimeters in height. So 2.2 is fair enough. Now it's ready. We put our screws over here, and then the nuts will hold this side. And now also even here, the screws head, especially if you don't have something like this in the screw head. I mean, it's not flat and then concaved. You have to make some kind of cutting over here so that it can flush the bolt along with the layer of the 3D printed part. And we equal them together, and then we say, and usually these 3 mm nuts and bolts, they come 5. So let's say we keep it 6 for safety, and because if it's greater, while you are putting the screw inside, it will try to take space, and then it's more likely that your 3D printed part will crack. So now oh, sorry, I did something wrong. And same thing, which is 2.2. And here it is. And to avoid injuries and disasters, let's just make them 0, not 0, that's 1. 1 mm is enough. Or let's say 0.5. And ta-da! This is done. Now, to take this to 3D printing, all we need to do is just convert it to an Stl file. And in Inventor, it's easy. Export, SCAD format, Stl file, and then you can keep it on the desktop. And if you go into options, just to make sure, you have to select millimeters because the dimensions that you have made is all in millimeters. And then you have to put this one to the lowest and this one to the max to give you the most best resolution, and use binary. Okay, save it. And now that it's saved, and you just can go take it to a slicer, and then after slicing, just start printing. And that's it for today. And this is the Autodesk Inventor.